Hi everyone, welcome to this week's lab demonstration video. This week we'll be going over the synthesis of a diphenylamine. Specifically, we'll be looking at 2,4-dinitrochlorobenzene and aniline in order to form N,2,4-dinitrophenylalanine. So a little bit about the relevance of this week's experiment. The product that we'll be synthesizing is a highly colored molecule that's used as a dye in a lot of different types of consumer products, such as candles, air fresheners, and types of beauty products. And the reaction mechanism that you'll be seeing today goes through a nucleophilic aromatic substitution. So a little bit about aromatic substitution reactions. One of the types of aromatic substitution reactions that we talked about previously is electrophilic aromatic substitutions. So here's the mechanism for that. For these ones, the pi electrons from the benzene ring are used to attack the electrophile, and then the intermediate that is formed is stabilized by resonance structures, and then in order to get the final product, some type of base removes the proton, and then you form your aromatic ring. But for today's reaction, we'll actually be going through a nucleophilic aromatic substitution. So you can see the mechanism for this week's experiment. Having the electron withdrawing groups on the benzene ring is important because it activates the benzene ring and makes this carbon right here electrophilic. So that way some type of nucleophile such as aniline is able to attack there. And then the intermediate that is formed here is highly resonance stabilized. For part of your pre-lab assignment, you were asked to draw all the resonance structures. So it has 5 total. And then a base is able to extract this proton here, and then you're able to get your final product. The reaction setup for this week's experiment is pretty straightforward. We're just going to mix the 2 starter materials in ethanol and then reflux for 35 minutes. And then for the reaction workup, we're just going to cool it back down to room temperature and crash out any product by putting it on ice. And then to isolate the product, all we're going to do is use a vacuum filtration. So make sure to take notes throughout the video, that way you guys can finish your in-lab report. Okay, so here we have 1-chloro-2,4-dinitrobenzene. We weighed out 0.751 grams on this tiered weigh boat. And then so you guys can see what it looks like. It's a solid and it's got a little bit of a light yellow color to it. Next, we're going to measure out 25 milliliters of absolute ethanol. Alright, so we'll start dissolving our 2,4-dinitrochlorobenzene. We're going to add it to this 100 milliliter round bottom flask and then add the absolute ethanol. And then we'll leave this spinning for a bit, and while this starts to dissolve, we'll go measure out our aniline. Okay, so here we're measuring out the aniline, and we're going to measure out about 1 milliliter of it. You can see it's got kind of a yellow or a reddish brown color to it. Okay, so now that our 2,4-dinitrochlorobenzene is pretty much dissolved, we're going to add our aniline to that mixture. And then here's just the summary of all the measurements that we made, in case you weren't able to see them on the video. So as you can see, we've added the reflux condenser to the top of the reaction. So we're going to turn on the heat. We've already got the water running, so that'll cool any vapors. And we'll get back to you guys when the reaction starts to reflux. Okay, so this is the 0 time point of the reaction. It just started to reflux. So make a note of any color changes throughout the reflex. We'll show you guys a couple time points, one at 15 minutes and then one at 35 minutes. So now our reflex is done. We're just going to take the heat off the reaction and then let this cool to room temperature. So while the reaction is cooling down to room temperature, just wanted to give you guys a close-up of what it looks like. So you can see it's still clear, but it's really bright red. So this is after letting the reaction cool for about 10 minutes. You can see that a lot of the product already crashed out of the solution. So you can see these crystals, they look kind of like needles. And the solids look like they're bright red as well. But we really want to try to get as much of the product to crash out, so we're still going to put it on ice for about 10 to 15 minutes. And then finally, to isolate our product, we're just going to do vacuum filtration. So we're going to wet the filter paper with a couple milliliters of cold ethanol and try to get a good vacuum on here. To help break up a lot of the clumps, we're just going to use a spatula to try to get as much of the solid onto the filter paper. And then we're going to wash the flask with 2 milliliters of cold ethanol. Try to rinse that out and get as much of the product out. And then we'll repeat this with another 2 milliliters of ethanol. Okay, so here's a close-up of what it looks like on the filter. You can see now, or you can see a little bit better the needle crystals on there, and they're still pretty bright red even after we rinse them with ethanol. So while that's drying, we're going to take a TLC. We have our two starting materials, aniline and dinitrochlorobenzene, and then we got a little sample of our product. So we spot them on a TLC plate and then developed it using 50% diethyl ether, 50% hexanes. So here's the image, so you guys can take RF values. And so this is what the final product looks like after it's been drying for a few days. So we're going to use this to take our melting point, an IR, and then a final mass. And this should be everything you guys need to write your final report. Make sure that you look on Blackboard. We have images of the TLC plate and then also an IR of the product.